Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and joining me today to talk about C++ stuff are David Lee and Michael Price. Hi, guys.
Hey Robert, how you doing?
Great. David, welcome back to the show. Michael, this is your first time on the show. Welcome to you both. Just give us a quick overview of who you are and what you're working on, and then we'll dive in.
Welcome everybody to What's New for C++ Developers. I'm David Lee. I'm the game developer product manager at Visual Studio.
And I'm Michael Price. I'm also a product manager on the C++ team, working with David to make sure that game developers' experience in Visual Studio is the best it can be.
Great. So we've done a few episodes before on game development. So this, I guess, is the latest round of that, and you guys are busy during the day, adding features. So we're gonna see what's new in Visual Studio. I guess since maybe the last time we did this, which was a little bit ago. David, what is new?
Yeah, we got a very exciting list of both for feature enhancements as well as performance updates. Michael, do you want to take us through the agenda?
Yeah. We're really interested in accelerating game developers' inner loop, right? And so when we talk about inner loop, we're really talking about three components. We're talking about coding, building, and debugging. And we've got great features to show in each one of these areas today. So for coding, we're going to talk some about how you can directly edit your Unreal Engine projects directly in Visual Studio without going through the Unreal Engine build tool generator. We're also going to show you a lot of cool new features with GitHub Copilot and how you can integrate that into your coding workflow to really accelerate your coding experience.
Well, that's awesome. It's good that C++ guys get all that goodness.
Yep,
Good sharp guys shouldn't get to hog it.
that's right. And then we're going to jump into the build section. And what we're going to show you with build is we're going to show you how you can drastically cut your build times using a tool we have called Build Insights to sort of analyze how your build is working and then identifying particular areas to go and improve. And then lastly, we're going to jump into some debugging. We're going to show you, we're going to explain some conditional breakpoint improvements. And then we're going to describe a new feature called C++ dynamic debugging that really helps you get your debugging under control.
All right. So before we begin, we want to give everyone a little thought into how Visual Studio views productivity. We have been talking to a lot of game developers in the past few years, and one thing that constantly comes up is the wish to reduce long iteration times. Because we know that when iteration times are long and perhaps your tools require you to mentally task switch to other applications, your focus might shift. And that's why we're really focused on creating tools that allow you to focus on building your game. Let's discuss some of the productivity features that we have been building in the coding portion of your inner loop. In the latest version of Visual Studio, you can now directly open new projects. So with this, you can open your Unreal Engine projects directly in Visual Studio. You don't need to generate a solution every time you make any file updates. And of course, with this new format, Visual Studio will have a much faster and accurate IntelliSense experience. For our console developers, Xbox GDK support will be available soon in the upcoming June updates.
Just to review, what did people used to have to do, and what can they now do?
The current way of working on Unreal Engine projects is you would either get your source from the marketplace or GitHub. You then need to build it using the Unreal Build tool and generate a Visual Studio solution. And once that happens, then you can open your Visual Studio solution. But the issue with that is we heard from a lot of folks that there is some sort of friction every time a file needs to be added, just because Unreal Project is a different type of project that Visual Studio understands. With the U project updates, we have also made it easier for folks to acquire the Visual Studio integration tool, which is our Unreal Engine plugin that makes all of this work. So you can now install the plugin using a one-click install inside the configuration page in Visual Studio. For those of you out there who want to take a peek into the plugin itself, we have open sourced this plugin on GitHub, and you can visit aka.ms/vsit. Lastly, we definitely heard a lot of feedback about perhaps this tool wasn't that easy to use before, and that's why we added the ability to install this inside Visual Studio and to remove the dependency so that you can use your blueprint references for Unreal Engine projects without this plugin. Now, for those of you who are using the Unreal Engine test adapter, running this plugin in the background will greatly boost the performance. So let's move on to the newest feature in our suite of Unreal Engine integration, and that is the new blueprint debugger. Next time that you're debugging your Unreal Engine game, you can now see Blue Engine specific frames. In your call stack window, you can see the tag blueprints. And when you inspect locals on those particular prints, you're able to see all your blueprint information while debugging. We hope this greatly accelerates your productivity and iteration time as you don't have to keep going back to your Unreal editor.
Yeah,
This
it's all
is
in one place. Less context switching. That's very nice.
Yeah, this is very useful, especially if you have a lot of blueprints that call C++ code. Especially in the cases that maybe you're not sure which ones call which code, and with Blueprint Debugger, you can actually go in and nativize a blueprint iteratively, convert nodes into C++ classes, rinse and repeats, all within Visual Studio.
Cool.
That's all for our Unreal Engine integration, but we want to show you our latest GitHub Copilot updates.
So previously, in previous iterations, and I'm sure you've seen it in other places, we've talked about GitHub Copilot, and we've talked about basically a few sort of major features of it, right? We've talked about GitHub Copilot chat that lets you have like a sort of natural feeling kind of conversation with the LLM in the background. We've also talked about GitHub completions that happen in the editor. So as you're typing your code, it sees kind of the things that are around, and then it makes a useful suggestion to you, thinking, oh, this might be what you need to type next. Can really save on lots of keystrokes. There are lots of great new features, though, that we've done for this past year, and we want to walk you through some of those. What we want to talk about today is removing the friction to getting started with Copilot. So this QR code will take you to an information page about how you can get started. So what we really want to show you, though, is that you can get started with one click. There's a little badge you can easily get started. And GitHub Copilot now has a free version, GitHub Copilot Free, where you don't have to pay to be able to use GitHub Copilot, at least in some limited form. We want to talk to you about a new AI-powered editing session feature called GitHub Copilot Edit that really brings code editing to the next level with GitHub Copilot. There are also lots of features we've implemented that are specific to C++ users. We'll show you some of those. And then we also want to talk some about the different ways you can customize GitHub Copilot for your environment. There are lots of different ways you can make it work for you in your environment.
So with all that said, let's quickly jump into a demo and see how all of this works in Visual Studio. Here in Visual Studio, one of the first things that you can see is the GitHub Copilot button onto the top right. With this button, you'll open up a new context menu with GitHub Copilot related actions, as well as a Manage GitHub Copilot subscription button. Clicking it will take you to a link that will help you set up and link your GitHub Copilot access to Visual Studio. Here on the screen, the first thing that you see is a custom instructions markdown file. We heard a lot from developers of the need to want to customize GitHub Copilot to your own liking. And to do that, you add this markdown file in your .github folder. So here are some examples. For example, I have added me and Michael as subject matter experts for Unreal Engine and Visual Studio. So imagine perhaps there's that one person in your workplace that is just the person for that specific topic. This is a way to tell GitHub Copilots to refer to that person every time someone interacts. And of course, I find myself doing this a lot too. I used to constantly r- tell Copilot, hey, let's be brief. Just give me the examples and be as concise as it can possibly be. So with custom instructions, this is how you have a list of instructions to tell Copilot before each chat or edit session is executed. So before we do that, let's go and see how you can take your edits to the next level with Copilot edits. Last year, we showed how you can interact with Copilots in a few different areas. We showed how you can interact with inline completions, with comments, code suggestions, as well as Copilot chat. This year, we have something new called Copilot Edits. So before we begin our code, let's just put it into a particular scenario. Okay, imagine that your studio has a hackathon. It's a 1 day hackathon, so every minute matters here. And whoever wins the hackathon will get their changes applied to the upcoming update to your game. So let's see how Copilot edits can get you started with prototyping code as fast as possible. So to do that, you can create a new edits thread. Copilot Edits is a AI powered and very focused editing session. So the difference between edits and chat is chat you can interact with copilots to reference your code, understand your code, but edits is really there for you to interact with copilots on a specific coding focus. So let's ask copilots change the character's color to random every time they move. Now that when you execute Copilot, Copilot Edits does a few different things. It looks through your references. So, for example, this could be the files that you have open on screen. You can see in this drop down, Copilot has found Lara character.cpp, Lara character.h, as well as the custom instructions markdown file. Then it will give you a specific game plan. It gives you a summary of what it is trying to do when it's adding this code. And of course, brings you the code in multiple files in multiple places so that you can go and review these changes. Here in the CPP file, our first suggestion has been include some header files. Okay, that kind of makes sense. We'll tab to accept, as well as this next one to add a change color to random to the on movement mode change function. That makes sense as well. The last code change is a change color to random. Okay, the code gets a mesh and then applies a randomized F linear color. Okay, sure. I think this is a very good starting point. You might have noticed some squigglies because we have not declared that function yet. If we use a Copilot edits window, we can then navigate to our header file and then see the suggested change. Private void function, change color to random. That makes sense to us. So let's go back to the CPP file and then continue to iterate on our code here. We know that we have applied this random color. Let's add some logging to check, for example, the color has been applied correctly. And to do that, we can add a comment, press enter, and Copilot will come up with a suggestion. Here you can see the line of UU log, warning with the text color change. That's good. Why don't we add another check to tell it to print out the color of the log? And then Copilot will suggest a particular UE log with a color. So here's something new. If you press Alt slash, you can now modify the code suggestions that Copilot has provided to you. So in this little diff window, I'm going to change, instead of a warning, I'm going to change that to log. Press accept. Copilot will have your suggestion. All right, great. There's still some squigglies here, so let's figure out what's going on. If we go over to the light bulb, you see, okay, maybe we have forgot to include something. Okay, we'll keep that in mind. Let's hover over the UE log macro to see what it says. Oh, okay. There we go. Identify random colors unidentified. Of course. So even though we have asked for a UE log of our color, we have declared our random color inside the if statement. We know how to fix this. Let's just move our code right after the color has been randomized. So we'll do that there. So once again, I'd like to reiterate that this is a really great and fast way for everyone to get started prototyping the code.
So that is just totally awesome.
Yeah.
So I know that Copilot, obviously one of the things it does is it gets its recommendations from code that it has looked at sitting in GitHub repositories. So I assume there's plenty and plenty of C++ code out there for it to learn what to suggest, or are we in kind of early days? What's the kind of status on that?
Yeah, and there's a lot of great open source repo out there that Copilot uses, but it also uses your entire code base when it's making these suggestions. So a lot of learnings is learned from the outside, but it'll look through your project in order to make the suggestions.
Okay,
So
cool.
for example, here, I had a comment for documentation. It generated that comment specifically using the code that is present in this file. And similarly here, we can see on the on movement mode changed, you can describe with Copilot. So once again, this is not looking at outside, but it's taking what is learned through open source projects as well as your code base to provide that description for the function that is undocumented, right?
Okay. Okay.
And you can even continue to talk to Copilot using the continue to chat feature. Here you can see I'm using the at workspace command. So this is explicitly telling GitHub Copilot that this particular prompt, this question I'm going to ask, reference my entire code base that is in this particular solution. For an Unreal Engine project like this one, this could be very large, but it will just look through all your references. For example, here I'm asking, okay, how has on move and mode change? How has change color to random this particular function used in other cases? I think that this is a great way to sanity check something, a code suggestion. So here, Copilot Chat gives me a bunch of references on where this is used in other places. You can continue iterating with Copilot Chat with the follow-up questions. For example, I think the next great question is, how can I modify the change color to random function for specific colors instead of random colors? This way, you're able to continue your conversation. And Copilot really makes a good attempt to guess the next question you want to ask. So, a lot of times I find this very useful in my day to day workflow because most of the time it actually knows what I want to ask next.
It's like it's reading your mind.
Yeah, definitely. When you see those sparkle signs, that's when you know it's Copilot. So here, Copilot told us, okay, instead of just having a randomizer, you can you can define a specific array of colors. Then just pick from an array of colors instead of truly random colors. Maybe I don't need this, but if I need to modify the way my code behaves, this is a great start.
Excellent. Cool.
So David, you added this function. What if I want to know what this function, what these things do?
So that's you can do that with the new triple slash. So last year we showed you how to document the code, and this year we have added a triple slash command so that you can not only have the summary but also the parameter summary. And when you hover over the symbol like you've seen there, um, Visual Studio will update the information in your quick info. You should have no excuses to not document your code.
So, David, are you saying that it only takes a few keystrokes to document an entire function?
Yes, that's exactly what I'm saying. All right. So, one of the last features I want to show everyone is you can select your models. We got a lot of feedback about making Copilot more customized, and here you go. You can pick from a variety of GPT models as well as Cloud 3.7, 3.5. Um, Choose your own particular model to your liking. Here with the GitHub command, this is how you ask the web, right? So I can ask something that's very recent and relevant, such as Unreal Engine updates. So, for example, what are the top changes in the latest Unreal Engine 5.5? And I can show everyone like a quick difference, right? Here we have GPT 4.0. There's different models that do different things. Some might have better performance, some might have better reasoning. So we put it in your hands. So the choice is yours to choose a particular model. Here I chose the O3 mini model instead. I suspect the answers will be the same, but perhaps maybe the format or the speed will be different. All right, this seems pretty nice, and I have links that I can go find out more. So that was all the great things in Copilot.
Yeah. So we really want to emphasize too that GitHub Copilot works with all source control systems, right? Even though it's from GitHub, it works with more than just Git. And we know that game developers often use other source controls that systems that are not Git, and this will work for you as long as you have a GitHub account. You can use GitHub Copilot. Your repo does not have to be hosted in GitHub or in Git at all for this to work. The other thing that we hear that kind of is a barrier for people getting started is like their company or organization is concerned about exposing sensitive intellectual property out there to the web. And so there's actually ways you can use what we call content exclusion, where your organization can like specify a set of files or paths inside your repository that the context for those things will never get sent across the wire to the model. This is a really good way to protect all of your information that's really super sensitive. And again, you can try GitHub Copilot free with just that one click. It's free, so there's no real excuse to avoid using it. Try it out and see what you think. And if you have particular ideas or if something worked great for you or didn't work, you should let us know.
Yeah, so we showed Copilot Edits. That is your new AI powered editing session. It will show you all the different edits across files with suggestions across your entire code base. We have showed you various ways that you can interact with Copilot to help you understand your code. Once again, with a few keystrokes, you now have no excuse to not document your code anymore. Lastly, we showed multi-layer customization that allows you to talk directly to the web with different model interactions, as well as setting custom instructions. So that was it for our code portion of your inner loop. Now let's move on to Visual Studio Build Insights. So last year we have showcased Build Insights Include view and Functions view. These views provide a very crucial information such as very costly include dependencies or expensive function generations. This year we're back with a brand new update for template view, which allow you to see template instantiation times. Build Insights has had great success with our first party developers. We have worked with Xbox Advanced Technology Group and Activision to reduce Call of Duty's build time by 50%. This is a huge undertaking for both the Xbox team and the Activision team because before we started this, the build time was at around 28 minutes. And with some analysis with build insights and then correctly applied code changes, we're able to bring that build time all the way down to 14 minutes. Imagine a 14-minute save to your big game across all your developers.
That's huge.
Yeah. We do have a very specific case study that we have posted. Please visit the link aka.ms/build insights MW2 to learn how exactly build insights was used, the different information exposed by the different views, and then how code changes were applied. All right, so let's get started with a live demo to show everyone how the template view works.
So what I have here is I have a very small solution that has a couple of projects in it. And these projects are using templates in particular ways that could be bad for compile times. So what I'm going to do is I'm going to go ahead and run build insights on this solution, so we can get a baseline so you can see how things are behaving currently. So I'm going to do run build insights on solution rebuild. I'm gonna make sure to do a rebuild. That way there's no like, oh, you already had it built and so it went fast or slow or something like that. This usually takes on this system I'm on, this usually takes about 10 minutes or 10 seconds or so. So like while this is going, previously in other demos and videos and recordings and blog posts, we've described how to use the previously included features like included files, include tree, and then functions to find where the bottlenecks in your build process are. And today we're going to focus in on this templates view instead. So this is loading up. You can already see that the build for this took about 15 and a half seconds. So after the data finishes loading up, actually, I will go ahead and switch to the templates view because that's a separate load. Okay. So you can see here, this is kind of explaining that we've got some templates that are really taking up a lot of time. This TL expected is taking up more than 11 seconds, and this at impl is taking up another 8 seconds. Now, these don't add up to 15 because these were running in parallel. So what I want to do is I want to actually go and investigate these things so I can figure out how to fix them. So the first thing I'm going to do here is I'm going to use this new project filter. This is a new quality of life feature we implemented. It lets you narrow down and look at just the projects that you're interested in at that moment. So I'm going to go ahead and just choose the Sfine expected project. Okay. You can see it seems like all of these things are related to this TL expected type. So let's go see what that type is doing. So I'm going to use our new all-in-one search capability. This lets you search across your entire solution, and it also has this great new scoping capability. So I'm going to scope to just files, and I'm going to search for expected.hvp. We get this nice preview of these files too, so you don't even have to open them up in the editor if all you want to do is look at the source code. If we look over here, we can see that this particular type is an implementation of the standard expected type, but it was written in 2017 by one of our colleagues at Microsoft, Cy Brand. I know that this type eventually was included into the standard, and we've since shipped that in the Microsoft STL. So I think that's a really low-hanging fruit if we just go swap that out with the standard provided version, and we'll see what happens with that. So we'll do that to fix this particular one. I'm going to close that window. Now let's look at the other project. So I'm going to go back to the filter. I'm going to select the recursive type list indexing. So this project is basically has a type list, which is a template meta program type of entity that is just a list of different types. And you may want to be able to index in to pick a particular type out of that type list. This add impl template is implementing that feature for us. So if we expand the template name, we can see all of the specializations that are getting instantiated because of the way this thing is implemented. Okay, So let's go explore this and see what's going on. We're going to use all-in-one search again. This time, instead of files, we're going to do types with T:\, at impulse. Okay, so we can see it now in our preview here. This is a pretty classic template metaprogramming trick. What this is doing is, in order to do the indexing, you actually derive from a recursive template. So this is creating a really nested inheritance model, and you're instantiating each sequence in this nested inheritance. It turns out that that's really expensive to do in the compiler. And there's an alternative way to do that that we'll look at in just a second. So we kind of know what the problem is. I have an idea of how to fix them. I actually have these fixes off in a perf branch. So I'm going to go ahead and switch to that branch. And I'm going to rebuild with build insights. And while that's happening, we'll explore what those changes are. Okay, great. Let's go look at what those changes actually are. So let's do a git diff between main and perf. Okay, so we can see here for the type list indexing example, what we're going to do is we're actually going to swap out that nested inheritance for just a flat inheritance, and we're going to use parameter pack unpacking instead of the recursive instantiation. Turns out that this is a lot faster. The compiler can process this pack expansion a lot faster than it can do recursive instantiation. So that's how we're going to fix that. And then you can see here, we're just swapping out that custom expected type with the one provided by the standard. Okay, that's our sets of changes. Now our build finished. So let's pull this over side by side so we can do a comparison. Hide that. There we go. Let's switch over to templates. So you can already see we cut our overall build time from more than 15 seconds to a little bit more than 9 seconds. It's not quite half, but it's still pretty significant. And you can now see that the at impl doesn't even show up anymore in this new. We completely made that negligible in terms of build time. And if we go back to our filter here, we'll do select all. Our TL expected took 11.5 seconds, but our standard expected only took 7.5 seconds. We really, really improved the build time for these source files. Now, this was just a few seconds for a couple of source files, but the way that templates work, right, is that they get instantiated in every main source file that you end up using, every translation kit. So you can imagine if you were using these types in every source file you had, you're shaving, a handful of seconds off of every file that you're building. And those can really add up over time and really accelerate your iteration time.
That was a quick demo of how you use the new template view to chase down all those costly template instantiations. We have also showed you some quality of life improvements. Really, all of these features are driven by your feedback. So, continue to talk to us so we can keep adding cool things. Next, we have our debugging portion of our inner loop. Let's get started with debugger performance.
Yeah, so one of the things we've made improvements on in recent Visual Studios is conditional breakpoints. So conditional breakpoints is a feature that lets you set a condition that gets checked on each breakpoint, that the breakpoint will only trigger when that condition is true. Now you can imagine though that every time the debugger comes across that line, it has to check that condition to see whether or not the breakpoint should fire. And that checking has a lot of overhead, or has significant overhead to it, or it did have significant overhead to it. In recent versions of Visual Studio, we've made this more than 2.5 times faster. So an example in our test case that we had where we were measuring 80,000 iterations, the time that it took to get through all of those checks was about 80 seconds. But in the newer versions, that only takes 30 seconds. So we really shaved off more than half of that time for your conditional breakpoints, which just means you'll get to do your debug cycles will go even faster than they did before.
And you can read more about it in our blog, aka.ms/fastcondbp.
And we should point out too that There's another quality of life feature for conditional breakpoints that whenever you go to set the conditional breakpoint, you can actually get Copilot to suggest what the condition should be for the situation that you're debugging, which is really cool.
Nice, nice.
Now let's move on to our last topic, which is debugging optimized C++ code. This is a feature that we've been working on a long time, and we actually have covered this in a complete separate episode.
Yep, link that in the show notes, but let's just review it.
Yeah, we heard a lot of feedback about the difficulties around dealing with optimized builds when you're debugging. For example, we heard a lot of stepping not being reliable, constantly seeing that variable is optimized away message. It just, a lot of difficulties because if you want to get around all that, you can either do a debug build when your frames are horrible or add pragma optimize, which just means you're going to be building your game over and over every time you want to look into some optimizations. Well, there's good news. We have introduced C++ dynamic debugging in Visual Studio 1714 Preview 2. So you can try this out today. And of course, if you want to see it in action, get to know a little bit more about how it works, don't miss our specific episode on C++ dynamic, dynamic debugging.
So that is very, very cool stuff, guys. Thanks so much for coming and showing this. Any closing thoughts before we wrap up?
I just want to continue to invite everyone to continue to give us feedback because this is how the team is really not only energized, but also gets inspirations from your issues, from your pains. This is how we understand what you want. So please continue to engage with us on social media, through developer community tickets. And if you're ever at a conference, do come and say hi.
All right. Thanks again, guys. Hope everybody enjoyed this, and we will see you next time on Visual Studio Toolbox.